The next report will be made by Oleg Gomozov from NITP.
Dear colleagues, I'm happy to welcome all of you. I'd like to correct the moderator. The stress is on the first syllable in my last name, Gomozov. You can see the title of my presentation on screen. Actually, I will cover more ground. I represent the production facility of precision instruments. Our institute is an old entity celebrating 60 years this year. In spite of this, we have a lot of young people working for us, and they are our future. It's not prohibited to brag a little bit at this conference. I can say that we do a lot of serious things at my company. One of them is Kurs and Igla, without which no docking takes place. Also, there is a high-speed radio line to transmit a lot of data from remote sensing satellites, then receiving and processing stations, both stationary and mobile, and a lot of other things related to instruments, data processing and control. With support of Russian Space Agency, we started dealing with geospatial data. We didn't start from scratch. We had gained a lot of experience prior to that using local satellites. Remote sensing data market analysis helps us to plan our activities. We identified some of the fields of activities and trends. There is a continuously increasing volume of remote sensing data, increasing spectrum of remote sensing data that have ever-increasing accuracy, radiometric, and other features. Also, there is growing competition and the number of suppliers and vendors. It leads to a situation where those interested can find several sources of data, and often you require good accuracy, cheap data. The analysis helped to identify some of the trends in market development and identify ways which we actually pursue. First is the creation of large processing centers using remote sensing data, creation of a uniform territorial geobasis in the shape of orthomosaic and DEM, increase of accuracy, and creating and developing infrastructure of geospatial information. These are the domains that I wanted to report the results on to you. During the first stage, we created a fairly large processing center to work with remote sensing data, but since I was lazy enough to draw computers, clusters, and storage facilities here at the bottom of the page, I provided a small summary table showing the features of our computing center. The capacity of clusters is over 12 trillion operations a second. The storage facility is 2 petabytes, and we have quite a big number of dedicated workstations equipped we believe, with cutting-edge technology in processing and geo-information domains. Instrumental to it was Rucker's company, so I commend them for creating such a wonderful product that helps to carry out large-scale actions, and it also helps to perform a lot of operations for smaller projects. This slide shows one of the primary products that we are working on at the moment. We called it the basic continuous cover in high spatial resolution. This basic cover is quite large by area, as you can see. We are working simultaneously on several projects. What are the specific features of this one? It is distinguished by a good quality of stitching and high accuracies. These are the key features that make this product stand apart. This product is based primarily on high-res and very high resolution imagery with very good accuracy characteristics. We take them from GeoEye. As we can see, the geopositioning accuracy is around 2 meters to 3 meters. Digital globe with the positioning accuracy 3 to 5 meters. We also rely on ALICE that are not as good in terms of RMS, but they have very good inner geometry. You know that these images are annotated with RPC ratios. This is a simplified model, but if good accuracy and geometry is provided, it can be used quite effectively. We assume, and our product is being actively implemented, so we assume that our product forms the foundation for many systems. It can be the basis for business subsystems, economic subsystems, nature subsystems. It can incorporate multispectral data collected by UAVs, and it can also contain a lot of object data that requires precision, geopositioning, and visual representation. A few words about the previous presentation. A short summary of conveyor by Photomod was provided, but we extensively use this conveyor when it comes to large area projects, and it has proven to be very effective. The declared productivity has been met. We're talking about 300,000 square kilometers per day using the conveyor. That's what we can do. Of course, the conveyor needs some tweaking and fine-tuning, but still, the use of Photomod conveyor together with the standard conveyor yield great results in terms of productivity and accuracy. On that account, I'd like to commend Victor and his team. That's a very good solution. Analyzing the geospatial data market further, we've come to realize that as we enter the market with our product, the users see that using it with other maps may be somewhat challenging because of problems of compatibility and interconnectivity. And that creates probably the biggest disappointment. So, in addition to this product, we offer some set of vector data that we named the vector data of basic map. Using that, users can build their own geoinformation systems. Very briefly about a new domain that we embarked on. We understand that electronic maps is a final product that we are eyeing, or it's even an interim product, so we are working actively on geospatial data. We are using the same basis to generate flat maps and 3D maps. This is the next best thing that we are addressing in terms of company development. When Russian Space Agency representative spoke, he mentioned the Uniform Territorial Distributed Integrated System. We are the developers of this distributed integrated system. A number of items have been introduced already. They contain geospatial databases, and they are linked between one another through the geoportal. The geoportal physically sits at the scientific center of the operational monitoring of the Earth, one of the Roscosmos's subordinate units. Using the interface solutions and the geoportal, users can connect their databases, thematic databases, shown here on the right-hand side. Many of these solutions have been implemented already to varying degrees. Ensuring accuracy characteristics of remote sensing data is one of the areas of particular interest. I mentioned that we design software in this field. This small site gives you raw data, the image that hasn't been rectified yet. I think you can see that this central airport line has a several pixel of deviation, and these internal shifts and distortions are something that we need to address and rectify. This one again, there are geometrical errors, double images, and others. To avoid that and make sure that Russian systems become similar to GOI and ALICE, the Russian Space Agency is conducting a large project to validate satellite monitoring and observations. The purpose is to provide high accuracy and better geometry. This project seeks to create a number of calibration and testing facilities that will be located across the globe. The purpose of the system is to ensure high quality of data, high accuracy for any part of the world, so that our space systems could execute tasks over any territory. Commercial, you know that the GLONASS system is developing quite well, in particular to address this task. In order to obtain such accuracy characteristics with GeoEye, we simulated what kind of characteristics on board systems must have. And this is the summary table. For that, the key features are high accuracy of determination of orbits. It should be at around 1 meter. Astro orientation that positions your cameras properly with the proper angle, and a few other parameters. So calibration should target this onboard characteristic, make sure that they are in line with what is necessary. I probably shouldn't elaborate on this slide. I'll skip it over. I wanted to show that we rely on full dynamic models of space systems. That includes a geometric model of the scanner and the orbital movement model, the model of movement around the mass center. And the idea is to yield high metric characteristics. Here are some of the details of the model that I omit. Thank you very much. My representation is over. Can I ask one question, colleagues? We can have one question, scholar. All right.